Alright, in this video we're going to put everything together finally. We're going to take this rational function and we're going to find all of the features that we've discussed so far. We're going to find the whole vertical asymptote, horizontal asymptote, y-intercept, and x-intercept. Okay, we're going to start with, and I like to start with the whole. So what we're going to do is we're going to begin by factoring both the numerator and the denominator. So that is going to end up giving us f of x equals, I'm going to GCF the top and get 5 times x minus 1. And then I'm going to factor the bottom into two binomials. And I'm going to get 3x minus 2 and x minus 1. Now, if you don't remember how to do that, you multiply a times c and get 6, and then negative 5. And then from there you find my two factors of negative 3 and negative 2. And then you factor by grouping. But I'm going to let you practice that one on your own. Okay, so now that we've got this factored, we're going to look for terms that are shared by both the numerator and the denominator. And I'm going to see that as x minus 1. So now what I'm going to do is I'm going to set that factor equal to 0, add 1, get 0, so I have x equals 1. So what I have is an x coordinate of 1 for my whole. So what I'm going to do is I'm going to go back to the original part here, the original function. I'm just going to look at the front two terms here, the terms that we're not using to find the whole, and I'm going to plug in my 1, and what you end up getting is 5 over 1, which just comes out to 5. So my whole at this particular function is 1, 5. All right, now we're going to use the same factored version of this to find the vertical asymptote. So remember, the vertical asymptote is I'm going to take every term on the bottom, and I'm going to find out what makes that particular term 0. All right, so I want to know what makes this 0, and I'm not going to use the x minus 1 because we've already used that to determine the whole. So that will not be a vertical asymptote because the whole is there instead of vertical asymptote. So now what I have is 3x minus 2 equals 0. Solve that for 0. Get 3x equals 2, so x equals 2 over 3. So x 2 over 3 is my vertical asymptote. All right, now I'm going to find the horizontal asymptote. Now I'm going to go back and I'm going to look at this original one. To me, it's a little easier to do for the horizontal asymptote. And remember, I'm going to decide what happens as x gets really, 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 really large or really, really small. So as I start to go towards infinity, all right, this minus 5 and this plus 2, they start becoming irrelevant, right? If I were to plug in a billion in there, that 5 is relatively unimportant. Same thing for the 2. And as I continue to make that larger and larger, this next term becomes irrelevant as well. So that the only two terms that are relevant are really just these first two terms here, right? And if I look at the first two terms, and I again look at x, as x becomes larger and larger towards infinity, here I would have infinity squared. So that's going to be much larger than the top. So my fraction keeps getting smaller and smaller and smaller. My horizontal asymptote is going to be going towards 0, which is y equals 0 for my horizontal asymptote. Then we're going to start to try and figure out what is my x-intercept. And again, if I know I'm on the x-axis, I know my y value is 0. Right? I don't know what that x value is. So in order to get 0 right here for my y value, the numerator itself has to be 0. Got to ask myself, what x value can I put in here to make this whole numerator 0? And that value would be a positive 1. But if you'll remember, I've already used this positive 1 over here for my whole. So therefore, I do not have an x-intercept in this particular function. Because remember, the whole overrides the asymptote. And then finally, we're going to find the y-intercept. The y-intercept we know is going to be an x value of 0 because I have not moved left to right. So essentially what I do is I go plug in a 0 for all my x values. And if you remember, this creates the whole. So those are going to be unimportant to finding the y-intercept. So I can just use the 5 over 3. And remember, we're plugging in a 0 for x minus 2, which ends up becoming 5 over negative 2. So my y-intercept would be 0, negative 5 over 2. All right. I know that's a lot, but I've got another one for you here to try. So go ahead and pause the video. Try this one on your own. We'll come back and look at it together. All right, so now you've had a chance to try this on your own. First thing I'm going to do is factor these two. And I'm going to factor a negative out of the top. All right, and then I've got x squared plus 10x plus 25. And we will know and notice that I can factor that to two binomials of being x plus 5 and x plus 5. Okay? Now I'm going to take the denominator and I'm going to factor that as well. Again, you can use this little x method here and get negative 30 over 7 and then get 10 minus 3 and then factor by grouping. But I'm going to let you do that on your own. And what you end up getting is x plus 5 and 2x minus 3. So there is my factored form of both of those. All right, first thing I'm going to do, I have x plus 5 on either the top and bottom. I know my x value for my whole is going to be negative 5 because that's the value that makes this factor 0. And then I'm going to take the negative 5, plug it into the other two terms. And then here you can see I get 0 on the top, which makes the whole thing 0. So my y coordinate there is 0, so I have a whole at negative 5, 0. And the vertical asymptote, and we've already said that these two terms come together to create the whole, so I'm not going to use that to find my vertical asymptote. I'm only going to find what makes this other factor 0. So I set it equal to 0, plus 3 plus 3 at 2x equals 3, divide 2, divide 2. So now what I have for a vertical asymptote is x equals 3/2. So now I'm going to find my vertical asymptote. Again, I'm going to go back to the original function here and look at this to find my vertical asymptote. And we got to look at what happens as x becomes infinity. So what we can notice is that minus 25 and minus 15 become relatively unimportant. Same thing here with this minus 10x and this plus 7x. Because these two numbers right here are all that matters, because when I square infinity, everything else becomes unimportant, right? And so even then I can notice, okay, well now I've got an x squared and an x squared just become a value of 1, which leaves me with negative 1 over 2. So as my x gets larger and larger and goes towards infinity, the only thing that matters would be that invisible negative 1 that we have out in front here, and the 2, which would give me my horizontal asymptote of y equals negative 1/2. Alright, now we're going to find the x-intercept. Alright, and what we're going to do is we're going to say, alright, so again, these two terms right here create my whole. So those are not important to finding the rest of everything. So now I can look at what makes that y value 0, and that would be to make this term 0. And to make that term 0, I would need x equals negative 5, which would tell me I have x-intercept at negative 5. However, if I look up here, I can see I already have a whole at negative 5. And so because I have a whole and an intercept at the same spot, the whole is what takes precedence there. And so what you would say you have none. And then finally, we're going to find that y-intercept. That y-intercept is when x equals 0. And all I have to do is plug those in. And remember, we said this was the whole, so it's not important in finding the rest of this. So I'm going to take that 0 and plug it in. And don't forget, we have this negative out in front that can be kind of tricky, easy to overlook. And then I have 2 times 0 minus 3 at the bottom. So that becomes negative 5 on the top, becomes negative 3 on the bottom, which is just a positive. So I have a y-intercept of 0 and 5 over 3. All right, I hope this video helps. Practice, practice, and we'll see you in the next one.